What's up, everybody? Uh, well, here we are. Everybody's hopefully quarantined in your own house. So, yeah, this is how class is going to be for the rest of the semester, I think. Hopefully it's not that big a deal. I mean, I have this big whiteboard here. I didn't really think about the lighting problem, so you guys are going to have to, let me know if you can see. I'll try to write big and dark. But what I want to do is just exactly what we would do if we were in class. So I'm just going to pretend that I'm in the room, and that you're right there. So we missed a week. This is one thing that's everybody's kind of dealing with. So my strategy on that is I'm just going to axe a lot of Chapter 5. So I'm going to be just checking to make sure this is recording a bunch too, because I one take it. I want to just get into Chapter 5 right now. So where we left off last was at the end of Chapter 4. We were talking about factoring. We were just doing solving quadratics using factoring. I normally would do a little bit of review on that, but Chapter 5 has to do a lot with factoring anyway, so I think you'll get this kind of like repeated practice throughout the rest of the semester with it. We've got to do the Chapter 4 test still, so I'll talk a little bit more about that in the coming days, because we can't use the testing center anymore, obviously. So let's just jump into Chapter 5. What I plan on doing is Chapter 5.1, Chapter 5.2, and Chapter 5.5, and that's it. So just axing out pretty much the entire chapter, other than what I think is the most important bits in terms of what you're going to use later on. So here we go. This is Chapter 5. Chapter 5 is all about rational expressions and equations. So this is what that means. Rational in this context means ratio, not like rational, thinking rationally. Ratio is a fraction, really. This is what a rational expression is. It's a fraction that has algebra in it. So 2x divided by 3x. That's a rational expression. In fact, just 2/3 is a rational expression as well. So really, when you just when you hear rational expression, all that means is fractions. Chapter 5 is all about fractions, which is everybody's favorite. So what we're going to be doing with rational expressions is, first of all, doing some figuring it out work, what are they, what's going on type of stuff. But then you're going to do addition, subtraction, multiplication, and division of rational expressions. Do some simplifying. And these are all the tools that you would need to do what you really want to do, which is solve equations. So this is, again, the big picture thing, the skill that is going to be super useful for you continuing forward in other classes is solving equations of different types. In Chapter 5, the type that we're talking about is rational equations that deal with rational expressions. In order to do that, you need to know how to do the four main operations and to simplify. So there you go, that's what we're doing. So I think it's a really good idea to kind of just cover the square one, basics of fractions, because it really is the same exact thing when you put algebra into it. So just start off with something from pre-algebra, which hopefully is really easy for you. Something like 3/9. In pre-algebra, what you would do with something like this is simplify it. This is a fraction. This fraction could be reduced. So you should do that. You should reduce your fractions. Again, it's one of those things, like I said before, it's not technically necessary, right? 3/9, you could do whatever you want with 3/9. It's just one of these things that you should get in the habit when you're doing calculations and when you're working with things mathematically to put them in their simplest form, because that's it's just easier to work with things when they're smaller and more manageable. So I don't know how you simplify fractions, but the way that I think you should do it, because these are obviously going to get a lot more complicated. What I think you should do is think about it this way. You can write 9 as 3 times 3. Right, so I'm factoring 9 into 3 times 3. And now you can see you got a 3 on the top and 3 on the bottom, so they cancel. And since there's nothing on the top, really it was 3 times 1. Right, so those 3 goes away, and you get 1's left on the top, and a 3 is left on the bottom. So it's 1/3. Right, so what I'm trying to slow that down is, what we're really trying to say here is that the way that you simplify fractions to a large part is using factoring. Maybe you didn't do that explicitly when you did this in pre-algebra, but that's really what's happening underneath the hood. So let me give you another example. About like 5x squared divided by, let me say like 4x squared divided by, no, still don't like that. 20x 5, something like this. So here's a rational expression. Like, the only thing that makes it a rational expression is the fact that it is a fraction. Let me just make a point here really quick. This is an expression, it's not a rational expression. That's 4x squared. There's no ratio there. That's not a fraction. Right? As soon as you put in the fraction bar, it is a fraction. Now it's a rational expression. So that's really all it means. Rational expressions are fractions, simple as that. You want to simplify rational expressions as much as you possibly can. Makes it easier to work with them. So what I like to do in cases like this is, there's a number of ways that you can do this, but I work with the numbers and then I work with the variables separately. So I mean, if you really wanted to slow this down, you could write this rational expression as 4/20 multiplied by x squared divided by x fifths. Right, so I'm kind of like splitting up the numbers and the variables separately. Yeah, the reason I would like to do that is just because now it's maybe easier to see that you simplify 4/20 into 1/5, and you simplify x squared divided by x5 into 1 over x3. Which really should be written as 1 divided by 5x3. Right, so I like to separate simplifying fractions that have to do with numbers and simplifying fractions that have to do with variables separately. But I think a lot of people would just take this as is and just do that mentally. Right, you can say 4/20 is 1/5, and x2 divided by x5 is x3. Boom. Yeah, so you'll have to develop your own style. Regardless, let me make another point here. 1 divided by 5x to the third power is exactly the same as 4x squared divided by 20x5. Right, and I think this is objectively simpler. The point, like, to even make that clear, pick anything you want for x. Pick x equals 10 and plug it into this. Right, so 4 times 10 squared divided by 20 times 10 to the 5th, and see what you get. Then do the same thing here. Pick x equals 10, do 1 divided by 5 times 10 to the 3rd. You'll get the exact same number. It's because these two expressions are equal. Right, so it's just much easier to do your calculations with this one than it is to do your calculations with this one. Being that they're the same, why not use the easier one? Cool. All right, yeah, so that's a lot of the stuff you're going to be doing with simplifying. Well, with rational expressions is simplifying. One thing that should be brought up immediately with rational expressions is that there's kind of a problem immediately. Let me point this out. Let's take a rational function. About 3 divided by 2x. Now let's say 4 divided by 2x. So here's a rational function. It's not a rational expression. Now I've made it into a function. If I didn't put this function notation in here, it would just be a rational expression. The reason I'm making it a function is because I want to point out the problem with fractions in general that have variables in them. And that is that there is something that you can't pick for x in this case. For one thing, this function can be simplified, right? So I could write this function as 4 divided by 2 is 2, and that divided by x stays there. So right, I could simplify it into that. Okay, but still, this function can't take on the value 0. Try to find f of 0. And you'll get 2 divided by what? Who knows what that is? Can't do it. It's division by 0. Right? So throughout this entire chapter, that's going to be an issue. They're called restricted values. So you should, and you'll be asked to in the homework and on tests and stuff, to find the restricted values of rational expressions or rational functions. And really what it just amounts to is what's going to make the denominator 0, find that, throw it out the door. Can't have it. So here's an example of that. Let's take f of x to be 2x plus 1 divided by 3x minus 4. Rational function. So the directions that you'll probably see on questions like this is find the restricted values. Or it might just say find the domain of the function, which is something we've done before. It's kind of same idea. If it asks you to find the restricted values, that means find the thing that's going to make this have 0 in the denominator. Find that thing. If it asks you to find the domain, what you got to do is find the thing that makes this have 0 in the denominator, and the domain is everything except that. Right? So it's a little bit different of a question, but if I were you, every single time you were doing either one, I would find everything. So this is what I would do. This is a rational function. If you want to find the restricted value, all you got to worry about is the denominator. Numerator can be anything it wants to be. Numerator can be 0, numerator can be any number and 0, doesn't matter. Denominator cannot be 0, because then you have division by 0, and that's, we don't know what that is. So you just got to go like this. You just say 3x minus 4 equals 0, and solve that. Add 4 to both sides. 3x equals 4 divided by 3. X equals 4 divided by 3. So x cannot equal 4 divided by 3. This is a really common mistake you see people do a lot, is that you say x is 4 divided by 3. That's the solution to this equation that I'm just kind of using this as a tool. The point is that x can't be 4 divided by 3, because if it were, you get 3 times 4 divided by 3, which is 4, minus 4, which is 0, and then you'd have division by 0, which is impossible. So you got to say this. You could say something like the restricted value is 4/3. Right, so there is one restricted value in this case, and it's 4/3. Or you could say the domain of the function is the set of all x's such that x does not equal 4/3. Right, so you see the difference? Domain is everything except 4/3. The restricted value is 4/3. Cool. Here's another example of that. Oh, actually, here's one for you. So I'm going to give you a chance to do a problem and put it on a piece of paper, just like we would in class, and take a picture of that when we're done. I'll give you like 4 or 5, exactly like we do in class. And then just take a picture of your paper with your name and the date, just like we do in class, and then email it to me, and that'll be the in-class assignment. So try this. Here's a rational function. G of x is, say, 4x squared divided by negative x plus 6. Find the restricted values and state the domain. Just do it both, right? So find the restricted values of this function and state the domain of this function. Pause the video. No, you don't have to. I was thinking about making this like a YouTube video. Like go ahead and hit the subscribe button at the bottom. Put a link in the description, but I'm not going to do that. Maybe I will. I could probably edit some stuff in. I guess I don't have to give you time because you could just pause this and do it. So here you go. If you're going to find the restricted value of a function, all you have to do is worry about the denominator. So I see this a lot. You see this a lot when with people who are just learning about this. Is in order to find a restricted value of a rational expression or a rational function, the numerator doesn't matter at all. All that matters is the denominator, and all that matters is what makes this denominator 0. So all you have to do is take the denominator, make it equal to 0, and then solve that for x. Figure out what makes it 0. Figure out when this is the same as 0. Minus 6 from both sides. Negative x equals negative 6, which means x equals positive 6. So again, x isn't 6. The restricted value, so I would just write it out, something like this. The restricted value is positive 6. And then you could say the domain of the function is set of all x's such that x cannot equal positive 6. Cool. All right, here's another example of that. Let's take the function f of x equals x squared plus 6x minus 1 divided by x squared plus 8x plus 15. And same question, find the restricted value, or values, there's going to be more than one in this case, and state the domain of the function. So this is what you do, right? You find restricted values, numerator doesn't matter at all. Don't even worry about the numerator. To find the restricted value, only worry about the denominator. And only worry about what makes that denominator equal to 0. I really hope the sound is on here. Got to check that. So, this denominator equal to 0 is a quadratic equation. This is what we're talking about at the very end of chapter 4. To solve a quadratic equation, you put everything on one side, 0 on the other, and then you factor. X and x, because you got x squared. Two things that multiply to 15 to add to 8, 5 and 3. Plus 3 plus 5. Then you say something times something equals 0 means that one of those things is equal to 0, or the other thing was equal to 0, which means that x equals negative 3, or x equals negative 5. Right? There's always two solutions to quadratic equations. So there's in fact two restricted values in this case. So you just come over here and say the restricted values are negative 3 and negative 5. There's two things that you could pick for x that would make the denominator 0 in this case. If you were going to state the domain, there's a couple ways to do that, but I would just stick with this. Set of all x's such that x does not equal negative 3 and x does not equal negative 5. That's how I would say that. You could use interval notation if you wanted to. It's a little bit more involved, but I'm okay with that. So here you go. That's restricted values. You're going to be asked to find them, kind of in the beginning of the chapter. And it's good to just keep in mind, right, as you're working with rational expressions, it's easy to lose sight that there are some things that just aren't going to work. It's going to come back when you start solving rational equations. Because it comes a time when you solve an equation and you get an answer by doing algebra, but then when you try that answer, it was one of the restricted values, so it'll never work. So that's why it's brought up. You got to kind of keep it in the back of your head, that there are things that aren't possible with fractions because it makes the denominator 0. So it's good to just throw them out in the beginning. Just figure out what they are. If you can't use those, get on with what you're doing. Sweet. Okie doke. So what you really got to do for a while, and I mean really what I think we should spend most time on on the homework and practicing is just like the kind of just calculation type stuff from chapter 5, which is addition, subtraction, and multiplication. And the division is a bit, it's just kind of like, it's kind of a thing. So multiplication is the easiest in my opinion with fractions. And then addition and subtraction, that's what I want to do right now. Probably, then we'll call it good for today, for this first day. So yeah, if you recall, multiplying fractions together is pretty straightforward. It's exactly what you would think, probably. Like let's say you had 2/3 multiplied by 4/5. Right, so just even a fraction, 2/3, that's a rational expression. 4/5 is a rational expression. This is a multiplication of two rational expressions, right? And to multiply fractions together, you multiply the tops, you multiply the bottoms. So this is 2 times 4 divided by 3 times 5. Simple as that, which is 8/15. Normally what you would do is simplify that. You always simplify it as much as you possibly can. So if this was simplifiable, you should do that before you say that's my final answer. It's not, so we're good to go. Yeah, that's all it is. Once these get more complicated, there's a better strategy. So let me pop one up here. Say x4 divided by 3x plus 6 multiplied by 5x plus 10 divided by 5x7. Alright, so this is a pretty complicated multiplication problem. Right? This is, I think, a pretty complicated rational expression. This is a pretty complicated rational expression. You're multiplying them both together. So look, let me just make a point here really quick, that if you were to just do what I just said and multiply the tops and multiply the bottoms together, you're going to have a mess. You could do that. You totally could do that. It's just a better idea to use the FEA method. This is my proprietary method of multiplying, adding, and subtracting rational expressions together. It stands for factor everything always. This is how I do it. Just factor everything always, then see what's up. Right? So just to make that point clear, if you were going to just get to multiplying this, you would have to do x4 multiplied by 5x plus 10, which is a distributive property. So it would be x4 times 5x, which is 5x5, plus x4 times 10, which is 10x4. Then you would have to do this multiplied by this, which is another distributive property. And it just quickly becomes very complicated and pretty messy. Then you would have to take the result, see if that can be simplified further, yada, yada, yada. And it's just, I don't think that's the best way to do it. You can make your life a lot easier if you factor first and then see if anything cancels. Right, so here's what I would do. I would write x4 as x times x times x times x. So I'm factoring x4 into 4 x's multiplied together. 3x plus 6, you can pull a 3 out and write it as 3 times x plus 2. 5x plus 10, you can pull a 5 out and write it as 5 times x plus 2. And then 5x7 can be 5 times 1, 2, 3, 4, 5, 6, 7. So I'm writing out x7 as x, x7 times. Now that you've done that, you can see that there's going to be some things that cancel. There's an x plus 2 on the top and the bottom, so those go away. There's a 5 on the top and the bottom, so those go away. And there's 4 x's on the top and 4 x's on the bottom go away. So look, all that's left is a 3 on the bottom and 3 x's on the bottom. So this just simplifies to this. There's nothing on the top, which gives you a 1. There's always a 1. So if everything goes away from the top, it's a 1. On the bottom, you get 3 and x to the third power. Right, so it's using factoring, you can get to this most simplified answer way faster and way easier, in my opinion. Cool. All right, let me have you try one of those. Try one similar to that. How about 10x divided by 6x minus 12 multiplied by 20x minus 40 divided by 30x3. There you go. Let me make sure I wrote that down right. 10x divided by 6x minus 12 multiplied by 20x minus 40, 30x3. Good. Yeah, so give this a go. Simplify. I mean, multiply and simplify. That's what it says here. Multiply and simplify. Okay. So, pause the video. Hopefully. Try this. Here is what I would do. FEA. Just factor everything. Just factor everything. Factor this, factor this, factor this, factor it all. And then you can see if there's something on the top and something on the bottom, they can cancel. So 10x, there's nothing to factor there, right? It's just 10 times x. 6x minus 12, you can pull a 6 out, right? It is x minus 2. 20x minus 40, you can pull a 20 out and write it as x minus 2. And then 30x3 can be written as 30x times x times x. And just to make this even more explicit, I could write 20 as 2 times 10, and I can write 30 as 3 times 10. Right now you can see, look, you have an x minus 2 on the bottom and the top, so that can be canceled. You got a 10 on the top and the bottom, so that can be canceled. One of these x's from the top and the bottom can be canceled. And now you can just look at what you have left. I mean, maybe you can go even further here, because 10 can be written as 5 times 2, and 6 can be written as 3 times 2. So you can cancel one of these 2's. So you have a 5 and a 2 on the top only. 5 times 2 is 10. On the bottom, you have a 3 and a 3 and 2 x's. So that's 9x squared. 10 divided by 9x squared is the final result. Yeah. Great. Sweet. All right. Just see if there's anything else someone would do here. Oh yeah, the division. So, if you remember how to divide fractions, let's just say, let's bring back 2/3 and 4/3 and divide. Right, so when you multiply fractions, you do straight across the top, straight across the bottom. But when you divide fractions, it's keep, change, flip. I don't know if you remember this or if you've heard this before, but keep, change, flip is the way that I've always remembered how to divide fractions. Technically speaking, how you divide fractions is you multiply by the reciprocal. So keep, change, flip is a way to remember how to do that. You keep the first one the same, keep 2/3 as 2/3, change the division to multiplication, and flip 4/3 to 3/4. Keep, change, flip. And now it's just multiplication problem, which is easy. You go straight across the top and straight across the bottom. Although you can see here that you have a 3 on the top and a 3 on the bottom, so those cancel immediately. And then 2 divided by 4 is 1/2. So it becomes 1/2. Which again, you could have written 4 if you wanted to as 2 times 2, and then canceled the 2. So, I like to overuse factoring. I just factor everything, always. Right, so when this becomes algebra, it's really the same exact kind of problems. Like, look, let me show you. 12x8 divided by 3y4. 3y4? Oh yeah, I guess they're thrown in y's. Divided by 16x3 divided by 6y. Alright, so here you go. This is, it says divide and simplify. Divide and simplify. So this is what I like to do. I just keep, change, flip straight away. Keep, change, flip, and then just run it like just before. Then it's just a multiplication problem. Factor everything always. See what's up. Cancel, cancel, cancel. Blah, 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 blah. So the division problem is really, it's nothing new. It's just make it a multiplication problem by doing keep, change, flip, and then business as usual. Right, so I would immediately rewrite this as 12x8 divided by 3y4 multiplied by 6y divided by 16x3. I did a keep, change, flip. Now you factor everything and make your, maybe you don't have to factor everything, explicitly. Like 12 divided by 3 is 4 straight away, right? And then there's 8 x's on top, 3 x's on bottom, so you end up with an x5 on top. There's 1 y on top, 4 y's on bottom, so you'll end up with a y3 on bottom. And then 6 divided by 3 is 3. So, just doing this all mentally, 12 divided by 3 becomes 4. 6 divided by, oh wait, yeah, shoot, so never mind. I'm already using that 3 up. Getting ahead of myself. 8x divided by x3 would be x5. y1 divided by y4 would be divided by y3. And then 6 divided by 16, what would that be? 3/8. So 3 down, 3 on top and an 8 on the bottom. 3 times 4 is 12. I'm doing this the super long way, so feel free to do this a different way, but then 12/8 becomes 6/4. Oh, which becomes 3/2. This is my ridiculous way of reducing fractions. 3x5 divided by 2y3 is the correct answer. The fully reduced answer, I should say. As long as you do everything right, it's always correct. You just always want it to be in its lowest form. So it's standard that we do. Cool. All right. Well, that's just about... Now, let me give you one more example. I want to show you another example of this. How long we're at here? Okay, that's 30 minutes. I want to keep these to be, roughly an hour. So here's another example of this. Let's say x squared minus 16 divided by x squared minus 10x plus 25 divided by 3x minus 12 divided by x squared minus 3x minus 10. All right, so pretty gnarly, rational division. It says divide and simplify, right? This is a pretty gnarly expression. First of all, since it's two rational expressions being divided, the very first thing I would do is keep, change, flip, make it two rational expressions multiplied. So that's my first move. I'm going to rewrite this, and look, I'm just going to do it in place. Right, so I'm just going to change this, keep, change, flip, x squared minus 3x minus 10, 3x minus 12? Yeah, cool. Right, so keep, change, flip straight away, boom, good, go. Now, what I would do is FEA, just factor everything, always, then see what's up. This is a difference of squares. It can immediately be factored to x minus 4, x plus 4. This is, a second degree trinomial. You can factor it as two binomials multiplied together. You get x and x. Two things multiplied at 25, add negative 10, negative 5, negative 5. This one, on the bottom, you can pull a 3 out and make it x minus 2. Oh, sorry. When you pull a 3 out, you get x minus 4. This one here is x and x. Two things multiplied at negative 10, add negative 3. Oh, it's 5 and 2. Minus 5 plus 2. Right, so now I have it written out in factored form. Once it's all in factored form, you can start making cancelizations. So look, you got an x minus 4 here, and an x minus 4 here. So those go away, those cancel. You get an x minus 5 here, and an x minus 5 here. So those cancel. I think that's it. All that's left on the top, let me pull it up over here, is an x plus 4 multiplied by x plus 2. All that's left on the bottom is a 3 x minus 5, which I would write like this, right? Rather than x minus 5 times 3. Not that that's wrong. It's just, usually when there's a number multiplied by a binomial, you put the binomial on the left-hand side. So I would write it like this if I were you. Also, the question comes up a lot is that, should you multiply this through now? Like, should you FOIL this and should you distribute this 3 through? That's up to you. Honestly, I prefer it written like this. So if it were me, I would say boom, just like that. That's it, done. And the reason is because usually when you're doing stuff like this, like if you're going to be doing this type of calculation or this type of simplification work for any type of application, like another class, the result, you're going to take that further and do other things with it. And I've just found it much easier to keep things factored than I have to multiply them out into their, longer polynomial form. So, if you're looking up the answers in the textbook, or if My Math Lab explicitly asks you to multiply it out, then do that. But if it doesn't, I find this to be easier format to present in. So I just leave it like that. By the way, with that said, you always want to make sure that you've simplified as far as you can. If you haven't, do that. Simplify as far as you can always, and present your final answer, in whatever form you're comfortable with. But I like it this way. Cool. All right. Well, that's about it for chapter 5.1. It's just a lot of that stuff, It's just a lot of factoring, a lot of simplifying. Canceling things from top and bottom. So I'm just going to put a bunch of problems in homework like that. Have you practice that a bunch, and then we can pop into addition, subtraction on Wednesday. So I'm just doing like a test run here. What was that? So it's about 40 minutes. Feel free to give me some feedback, right? Like if you can't hear, hopefully that's not a problem, but or can't see, or if there's any problem, just let me know as we go throughout the rest of the semester and get this figured out, hopefully online. All right, y'all. Stay safe. See ya.